Okay, we finished half of the chapter 5 already, and we'll jump back to chapter 4 because we have learned what's the domain, what's the range, and now we can consider the graph and then talk about what's the domain, what's the range. That's why I changed the order a little bit. For chapter 4, we have, I think it's about 5 graphs or 4 graphs to sketch. So hyperbola, truncus, square root, and then we add a cube root, which is not in the book, but we do that as a supplementary material. And then circle, semicircle. So it's about 5 types of graph we need to sketch. Then we start to learn the first one. You can see, I'm not sure how many of you sketch graph by using transformation. Like you think about what has been done, like translate 2 units to the left, 1 unit up, and stretch. Actually, I'm not using transformation method to sketch a graph. Okay, I have my other method, like by see the key features. Okay, it can be like see key features to sketch the graph. So let's have a think about the hyperbola, like rectangular hyperbola. If you learn Spech, there are other hyperbolas as well, but this one is called rectangular hyperbola. Okay, the simplest hyperbola equation is fx equals to 1 over x. Okay, so 1 over x. So it's actually a fraction. Okay, it's actually a fraction with number on top and a linear at the bottom. Okay, with number like 3 over 2x plus 2. That's a hyperbola function. Okay, that's a hyperbola function. It requires a number on top and require a linear at the bottom. Okay, that's how you recognize whether it is a hyperbola or not. The simplest graph looks like this. That's 1 over x. Okay, that's 1 over x. So the key feature for this graph is we have 2 asymptotes. Where's my graph? Come on. Stuck. Oh, it's come back. Okay, so we have 2 asymptotes. So one is the vertical one. Okay, it's can't see on the graph. So can you just label it by yourself? You need to label it out with dashed lines. Okay, with dashed lines. You need to label that clearly. And then there's a horizontal one as well. Okay, that's y equals to 0, and the other one is x equals to 0. Okay. One of the key features is for all the rectangular hyperbola graph, you will have 2 asymptotes, one horizontal one and one vertical one. I'll tell you how to find that later. But we have 2. We need to label that clearly. Second thing is what asymptotes means. Asymptotes means when the graph, like, can you see the graph when approaching to infinity, go to right hand side. The graph is get closer and closer to that line, but you never touch on that line. Okay, so your graph, when the graph get approached to 0, the graph just getting larger and larger, but you never touch the y-axis. Same as the horizontal part, you will never touch the horizontal asymptote. So the graph will approach that infinitely, but never touching it. Okay, never touching it. Okay, just let you know, you will have the test, right? I'm not sure how other class like mark this, but I'll let you know. You need to sketch this graph in a particular way. When you have graph for asymptotes, in the end, okay, the 2 tails, you need to get it parallel to the asymptotes. Okay, the graph needs to be parallel to the graph and get close enough to the asymptotes. You can't show you touching, you will be, okay. Okay, that means get close enough and parallel to the asymptotes. If you can see my example here. Why it needs to be parallel? The definition tells you that you need to get infinitely approach to that line, but never touch on that line. But you know I can only draw part of the graph. If your graph is not parallel, let's see if that's the asymptotes. Your graph is this direction. This is showing a trend. Your graph will touch the asymptotes. Okay, your graph will touch the asymptotes. If your graph is like this, you're showing a trend, your graph is far away from the asymptotes. They are not approaching. They are not get closer and closer to the asymptotes. So therefore, you need to get the graph parallel to the asymptotes in the end and then get close enough to the asymptotes. That's how VCAR marking your paper. Okay, so see, do you understand what's the definition for get approaching to? Okay, so graph needs to be parallel. So those 4 ends all needs to be parallel to the asymptotes and get close enough to the asymptotes. I know it's very strict, but that's how it get marked. So you need to be careful when you sketch a graph. Get it right at the beginning. If you show me a graph like this, I'm not going to mark it right, okay? Even though I know you understand the graph, but it's not showing approaching, I will mark that wrong. Okay, make sure your graph is parallel and approach to the asymptotes. Okay, back to the equation. We won't always have the simplest equation. We won't really always have 1 over x. We will have a more complex form. That's the general form. That's the same as the turning point form, for example, for the quadratic. So that's the general form for hyperbola. So you can see that A is constant, and that's a linear at the bottom, and we also can add another constant at the back. Okay, that's a constant as well. So we have a constant of the linear plus another constant. That's a hyperbola form. Well, if we go back a little bit to think about the domain and range for this graph, okay, the asymptotes means you can't reach that value, okay, you can't reach that value. Therefore, the domain will be r except 0, and the range is r except 0 as well, because you can't get x equals to 0, you can't get y equals to 0. So actually, the domain for a rectangular hyperbola will be r except the vertical asymptotes and r except the horizontal asymptotes. When we sketch graph, you can see this, okay? This means, well, we have asymptotes at x equals to 0, means x can't be 0, okay? X can't be 0. We have asymptotes at y equals to 0, means y can't be 0, okay? Y value can't get 0. That's why we have asymptotes here. Okay, I will write the steps to sketch a hyperbola. Okay, I'll write the steps out for you. So the first step is label XY asymptotes. Okay, asymptotes, the one of them must be y equals to k. Okay, that is the y value, like the constant you add at the back. That is your horizontal asymptotes, the k value. Okay, the last constant you add will be the asymptotes for y, the horizontal one. How do we find the vertical one? Okay, how do we find the vertical one? Let's have a look at the example below here. If you can see the example, for example, example 2. Just have a look, you don't need to sketch. Just have a look at the denominator here. The denominator is 2x minus 4. We don't have it in the form of x minus h. We have like ax minus h, okay? So the easiest way to solve this will be solve denominator equals to 0. You will have x equals to something. That's your vertical asymptotes. Why we solve denominator equals to 0? Let's connect everything we learned together. Think about the implied domain. There are 3 things that I said there's restrictions for the domain. One is the denominator, right? The other one is the square root, or like any even root. The third one will be a log. We haven't learned that yet. So we are going to like sketch a function with denominator with x. Therefore, your denominator can't be x. It can't be 0. Therefore, if you make your denominator equals to 0, the value gives you will be the problem value. Okay, that value will become the asymptotes. You can't reach that value. Your domain needs to get excluded of that point. For example, the example 2, the denominator is 2x minus 4. We just make that equals to 0. X will be 2. X equals to 2 is your vertical asymptotes. Okay, x equals to 2 is your vertical asymptotes. X equals to 2 means a line. All the coordinates on this line got x equals to 2.
Does that mean that in the equation where you have your general equation for hyperbola, your k value would be the
horizontal value? Will be the horizontal value. Okay, let's go back. That's the first step. We will see whether is what's the two asymptotes. Okay, second one is very easy. Okay, second one is you make sure where is your two graph. Your graph can only be in this code. Well, it's not really the XY. This is the XY asymptotes. Okay, you can either in those two or in those two. With your asymptotes, it's cut. The quadrant is cut by your asymptotes. So it's either in first and third or second and fourth. When is in first and third, that's a greater than 0. When is second and fourth, your a needs to be less than 0. But one thing you need to make sure. Okay, one thing you need to make sure. I can have 2x, I can have 3x, but you must have a positive x at the bottom. You must have a positive. I can have 2x, I can have 3x, I can have a half x, but it must be a positive number. So you need to have positive number of x at the bottom, and then you go to look at the top number, whether it's a plus or a minus. Okay, if a is a positive, then we have those two quadrants. If a is a negative, we have the other two. That's just this graph. This graph is very easy to sketch. I'll show you an example and it will make more sense. Okay, let's have a look at the first one. Y equals to -3. And x plus 2 equals to 0. X equals to -2. That will be the two asymptotes. Okay, that will be the two asymptotes. Let's sketch that first. Let's sketch that first. X is -2. So we have a vertical line at here. And y equals to -3. Okay, that you need to label that. Okay, we need to label the asymptotes. Remember that x equals to -2 and y equals to -3. The next thing is we roughly see where my graph should be. Okay, where my graph should be. The top number is a positive number. Okay, my x, first of all, my x is a positive x. Then I have a look. The positive is a positive top number. So we will have in the like this direction. Okay, right top and left bottom. So I will roughly sketch a graph. Okay, it's not finalized. It's this shape. Okay, it's not finalized. Why I want to sketch that? Because I can see there's XY intercepts. Okay, there's XY intercepts, but I don't know where is it. I need to make sure where's my XY intercept first. I'll solve for my XY intercept. So I'll say when x equals to 0, y equals to 1/2 minus 3, y equals to -5/2. When y equals to 0, 0 equals to 1/x minus 3 plus 2 minus 3. So 3 equals to 1/x plus 2. 3x plus 6 equals to 1. 3x equals to -5. X equals to -5/3. So the point is 0 minus 5/2, and this one will be -5/3, 0. Just as linear, we solve for XY intercept. Then we will put that on. Okay, so we get rid of that. We know where is it now. I need to make it more accurate. So we have y-intercept here. X-intercept is about here. Okay, trying to connect the graph. Okay, connect this. Can you see my graph like get close enough and parallel to that? You can't touch it at all. Also, your asymptotes must be longer than your graph. Okay, your asymptotes must be longer than your graph. You can't have like my graph like this, my asymptotes is here. Okay, that's not working. Your asymptotes must go longer than the graph. Okay, I'm not finished. Okay, the other half of the graph. Okay, like this. Minus 5 over 3, comma 0, 0, minus 5 over 2. You don't need to. You can, but I'm not suggesting. Like, if you put a point in the end, that means my graph stopped. If there's no point in the end, which means your graph keep going, you don't need the arrow to show the graph is keep going. But like the problem is if you draw an arrow, you may touch the asymptotes. You may touch the arrow may touch the asymptotes. It might be wrong.
Are you saying this is what you say for like everything for parabola?
Yeah, they're all the same.
Okay.
You don't need to show arrows means they keep going. If you not put a stop point, which means the graph is keep going.
But on the x and y axis still.
Axis you put arrows. Here you put arrows. Yeah. Okay. Well, I should extend that a little longer. Okay, that's my graph. So, just a suggestion. If can you see like there are two branches? Like on the left hand side, we don't have any point on that. We better find a point to give a coordinates to make it more accurate. Okay, to make it more accurate. For example, I can choose that point. That point is -3. You can calculate. Well, any point. Okay, not necessary to be -3. You can choose any point. So when x equals to -3, y equals to 1 over -1 minus 3, y equal -4. So actually, I can find where is -3 minus 4. Okay, this point is here. Just like you better label something, you can't just random sketch a graph, okay? Just better with a little bit dilation, you can see this. Yes?
Why did you put x as -3? Is it just a random number?
Just as I said, it can be any number. Yeah. It's just easy to calculate. You can see -3 plus or 2 become -1 for the denominator. Well, any number to the left-hand side of -2 because you want to select a point to the left-hand side. Yes?
So for that, we always have to label the intercepts, and if there are no intercepts, just
Yeah, like you always need to label intercept, but like you need to make sure at least there are 2 points on a graph.
Okay, so for this one,
if you not label, that's alright. Like if you don't label this one, it's alright. Just for yourself, like better sketching it.
yeah, okay.
Yep. Roma, do you have a question?
So you don't need all -3.
You're not necessary to put it there. It's just a suggestion. You better put it there.
Oh, so you recommend it?
I recommend to put a point here. It's just more accurate. It's just more accurate to sketch.
Point, yeah.
Yeah.
It just never puts the estimate.
Okay. Just make it clear. Shh. You must label the XY asymptotes. You must label the XY asymptotes with equations. Okay, with equations. That's the equation. You must label XY intercept. Okay, if there's XY intercept, you must label that. For a whole graph, there needs to be at least 2 points. Okay, for a whole graph, there needs to be at least 2 points labeled. For example, linear, if you just have one x-intercept, one passing through 0, 0, it's not enough. You need another point labeled. Okay, so we have 3 labeled, which is quite enough. The third one, because I want to be more accurate to sketch this graph, that's why I put a point here. I can select any number. Well, just -3 is the easiest calculation one, so I select -3. You can select -10 if you like. Okay. Let's talk about the domain and range for this one. What's the domain for this equation, for this graph? Yeah, all real numbers exclude -2. That's right. You can't take -2. Must put -2 in the curly bracket. You can't have -2 by itself. It must be a set difference with another set. What is the range? Yeah, all real numbers except -3. That's true. Okay, let's keep going. For example 2, well, I already find out the x asymptotes already. What's the y asymptotes? 1 or -1? 1. Okay, y equals to 1 will be the asymptotes, and x equals to 2 is the other asymptotes. Let's just sketch that. I have a really important concept needs to talk about, so let's be quick to do this one. So I have explained how we find x equals to 2, because that's the point where you make the denominator equals to 0. So x equals to 2, you can't take that. And y equals to 1. Y equals to 1 is here. Remember to label the equations. Okay, remember to label the equations. That is y equals to 1. Okay. Positive graph or negative graph? Negative, because you put this negative here and then that's a +1. Okay, so the graph can become this. So it's a negative graph. Our half graph looks like this because it's negative graph. I can see XY intercept, right? I can see XY intercept. Therefore, we need to find XY intercept. When x equals to 0, y equals to 1 minus 3 over -4. Okay, -4. And that's 7 over 4. When y equals to 0, 0 equals, well, let's say 1 equals 3 over 2x minus 4, because they need to be the same. So 2x minus 4 needs to be equals to 3. 2x equals to 7, x equals to 7 over 2. So I should be able to solve xy intercept. So get rid of those two graphs. I have 0, 7 over 4, and 7 over 2, 0. Just here. Okay, so 2 points needs to be labeled and 2 equation needs to be labeled. 2 points needs to be labeled and 2 equation needs to be labeled. That's how we sketch hyperbola graph. what's the domain? All real numbers except 2, and the range is excluding 1, which is the Y asymptotes. So we need to discuss domain and range. The domain is R except the X asymptotes, and range is R except the Y asymptotes. Okay, everyone, when you finish this one, please listen carefully. Just listen to me explain this first, and then if you have any question, you ask this. Because it's a really important concept. Year 12 papers always have this type of questions. Ask you to show a linear over linear is a hyperbola function. Okay, so first of all, you need to understand a linear graph divided by a linear graph, that is a hyperbola. Okay, that is a hyperbola. So how we can make into a hyperbola is by doing long division. Okay, I hope you know how to do long division. Okay. Well, I have other methods to do this, but long division will be the quickest way. So let's try this one. 3x minus 4. It's very easy to divide linear and linear. 3x minus 4 and 2x plus 1. Okay, we use the first number divided by this first one. 3x divided by 2x, we have 3 over 2. No one learned long division last year?
We did, but it was a little different. Because it wasn't linear. It was
to higher degrees. So x squared.
Oh, but it's the same. It's just very easy.
Because it would be it would multiply. So
Yeah, we will multiply that in a second.
okay.
Okay, you will get it? Well, I'll teach long division for so many years, doing this way. 3 over 2 times with this equation here. You will have 3x plus 3 over 2. Okay, you use that number you just write, time with the dividends. Times that. Then you subtract between two functions. Okay, just be careful with the subtraction. It's a little bit terrible. Minus 4 subtract 3 over 2, or positive 3 over 2. So that will give me a minus 11 over 2. Okay, a minus 11 over 2. Use the minus 4, subtract the positive 3 over 2. Okay, so it's a minus 4, subtract the positive 3 over 2. That will give you 8 on 2 minus 11 on 2. And finish. That's done. That's linear divided by linear. It's really easy. You just do one step. Because you can't use this to divide that anymore. There's no x left. So this equation becomes, okay, just let me finish. Minus let's say 3 over 2 plus a minus 11 over 2 over the 2x plus 1. That's the top number. That's the remainder, still over the dividend. You see that? That's exactly the same as you do number divisions. Okay, you do not number long divisions. Just tidy up this equation a little bit. Okay, just tidy this up a little bit. Times 2 on both top and bottom, you have minus 11 over 4x plus 2. And then plus 3 over 2. That's exactly the same as a hyperbola equation. Okay, that's exactly the same as a hyperbola equation. Yes?
Why is it when you multiply the second fraction by 2? You don't multiply through.
I can't do that because I'm trying to enlarge the top and bottom for a fraction. Not changing the other thing. I don't want to change the size. I just want to make it looks better.
Right.
So I'll times top and bottom the same number for a fraction. That's not going to change the size of the fraction.
So it's just the same.
Yeah, just the same fraction. Any questions how we get here? How we get a linear divided by linear become a hyperbola? We do long division. Okay, we do long division. We write that into the correct form. Okay, when we divide, how do we express our result? We express our result like by putting this number as the k value. The top number is the k value. And then this is the remainder. Remainder needs to be put onto what you're trying to divide. Okay, that's the correct format. And then we tidy up the equation a little bit to make it look better format. And then we will have exactly the same form of hyperbola. So if we can see this, we can see our asymptotes will be y equals 3 over 2. And x asymptotes will be 4x plus 2 equals to 0. X equals to minus a half. So I will sketch it here first. Minus a half. And y have 3 over 2. Okay, positive graph or negative graph? Negative? Okay, we will have negative graph. Therefore, we have graph here and graph here. Roughly, okay? I can see XY intercept. Just listen, please. How do we find XY intercept? Well, I know we can find XY intercept. But which equation you use to find XY intercept? What's the quickest way to find XY intercept? The original function is the easiest way to find XY intercept. If you can see, I can sub when x equals to 0. F0 is just minus 4 over 1. That's just a minus 4, if you can see that. Okay, 0, 0, I have minus 4 over 1. I just have minus 4. When the y equals to 0, what you have is 3x minus 4 over 2x plus 1 equals to 0. And you only need to solve the numerator equals to 0. Right? You times the denominator to the other side. 0, 0 times anything is still 0. So x equals to 4 over 3. X equals to 4 over 3. So can you see? Yes?
Are there some cases in which you can't divide everything as x? Like if you have x outside the bracket and then x minus 3 equals 0?
That's a different case. That's not the same case. You can't divide both sides. Well, I'm not dividing. I'm times both sides. Can you see what I do? I times both sides by 2x plus 1. For this case, what you're trying to do will be divide x on both sides. It's different. You can always times the number on both sides, but you can't divide the number on both sides. You can't divide 0, so x could be 0.
Okay.
So that's why there's a possibility x can be 0, and then you miss the answer. Also, you can't divide 0 on both sides. So that's why you can't do this here. That's different scenario. So we have 4 over 3, 0, and 0 minus 4. Okay, 0 minus 4. Can you see that my graph is actually wrong? Can you see that? My graph is actually wrong. I have different XY intercept. Like the graph can go from this side or it can go this side. Okay, you can have both. You can have a negative x-intercept, a positive y-intercept, or you can have a negative y-intercept, a positive x-intercept. You can have like both ways. So I can put 4/3. It's about here. Okay, that's 4/3, 0. And the other one is, well, which is quite below here. The scale is not very good. Just make it longer. That's x equals to -1/2. Okay, that's my graph. Okay, I should have the correct place for XY intercept. Before I just roughly sketch it, I pass it through the wrong coordinates. Okay, after you figure it out, you know it should be a positive x-intercept, a negative y-intercept, not the other way around. And this side needs to make it, it's pretty good already. So okay, that's the shape of the graph. Any questions? Okay, then that's it for this exercise. You need to do the homework. The schema fork is online already for chapter 4. So you should do 4A now. Okay, exercise 4A. Chapter 4A, but chapter 5 you need to start slowly catch up on that. You can choose some of the questions to do it. Because I haven't put the thing on, we haven't done the functions. A lot of chapter 5 questions relate to chapter 4, so you can't really do most of the exercise. You only know the theory, but you don't know how to sketch the graph. So now you can start to go back to do chapter 5A, 5B.